If you're a C# developer and you've not used it yet, you've probably heard of Entity Framework. But what is it and what can we use it for? Let's figure it out in this video. Before we get into the video, please hit that like button, and if you want some more .NET content, then please subscribe to the channel. So what is the Entity Framework? Well, in a nutshell, the Entity Framework is an Object-Relational Mapping Framework, or ORM for short. These frameworks allow you to work with data using objects rather than straight tables directly in the database. So in this case, we'd be using classes. It means you don't have to touch the underlying tables and columns in a database, and provides a higher level of abstraction, therefore making things just that little bit safer and easier to manage. You can use your classes to create, update, delete, insert new records as you need to, and you can query records using the same query conditions you would use, like a where clause, for example, if you were using something like T-SQL. So instead of writing a straight SQL query, you will be writing a link query using Entity Framework and the objects that you've abstracted above your table. Instead of creating a database connection directly to the database, in Entity Framework you create what's called a database context. A context is an abstraction over that underlying database connection that gives you access to the tables and columns of your database in the form of classes and objects. You can also use Entity Framework to alter the schema of your database using a concept called migrations, which we'll go into a bit later on in the video. So for example, if you removed a property from a class, that could remove the underlying column from the database. So for this video, we're going to take what's called a code-first approach to Entity Framework. Now what that means is that we are essentially creating the database from Entity Framework in C# rather than creating the database schema from SQL itself. The alternative to this would be a database first approach, which is where you have an existing database with an existing schema and you need to create an Entity Framework context for that database, and then you would essentially scaffold that Entity Framework context on top of that existing database schema. We're not going to do that. We're going to start from the code and create the schema from C#. We'll cover creating a new database, querying and updating data in that database, and managing the schema with migrations. So we're going to use Blazor for this, but you could use any .NET application to create an Entity Framework context. You could use an ASP.NET application, you could use a console app, but for this video I want to use Blazor because we've been doing a lot of Blazor recently and it seems like a sort of natural progression. So we've got the sample application here. I'm in the weather forecast service at the moment. So the first thing we want to do is install the NuGet packages for Entity Framework Core. So I'm going to head over to Manage NuGet Packages for Solution, and in Browse, if we just search for Entity Framework and then press Enter, we should see Microsoft.Entity Framework Core. So I'm going to take this. I'm not going to install the pre-release because I don't want any surprises, so I'm going to use the latest stable, put this on my project. There we go, and click install, and that will install the Entity Framework Core packages. So we'll click OK for that. That should install everything. I think it's already done. And then we also want to install the provider for the database type that we're using. So we're going to use Microsoft SQL Server. So we need to install the SQL Server provider, but you can use Entity Framework with other kinds of databases as well, including MySQL. But obviously for us, we're just going to use SQL. So I'm looking for Microsoft.Entity Framework Core.SQL Server. And I want to select the latest stable and install. It's going to install that. And there we go. Okay, so now that we've added Entity Framework Core and the SQL provider, the first thing we need to do is create a class for our DB context. So I'm going to head over to my data folder. I'm going to right click it and click add, and I'm going to create a new class. And I'm going to call my DB context demo DB. So demo DB context. Okay, so there's our class. And I want to inherit from DbContext. So this is an Entity Framework class, and you can see it doesn't recognize the namespace. So if I click Show Potential Fixes, you can see it's suggesting Microsoft.Entity Framework Core. So if I use that, it works okay. Then I want to add a constructor. So public demo DB context. Just make this a bit bigger. There we go. And this will take a set of DB context options of type demo DB context. And I'll call this options. And we want to pass this to the base class because DB context is what we're inheriting from. So we'll pass those through. And there we go. So we've got our DB context set up. And what we'll do in a second, once we've got our database configured, is we will create a bunch of classes which will represent our tables. But first of all, I want to get a connection to the database set up. I want to get the context set up and available as a service in our Blazor application. I'm going to show you how to do that. So in order to create the DB context as a service, in Blazor we use what's called a DbContextFactory. And if we create a service for that in the program.cs, it means that we can use dependency injection to inject a DbContextFactory into any service that we use. So for example, in Blazor, we've got a weather forecast service, which is just a class that we use from the front end. But we could inject a DbContextFactory into one of these services, and then that would allow us to get the context we want, the database essentially, and we can then get any of the tables, query things, insert things, all that good stuff. So back in program.cs, I'll show you what I mean. We're going to go to builder.services.addDbContextFactory, and then the type of context factory will be demo DbContext. So that's added a DbContextFactory to the services of our applications, which means we can use it as part of dependency injection elsewhere in the app. Now remember that our DB context, now at the moment we've created a DB context factory with just a plain demo DB context, but remember our constructor takes DB context options, so we need to pass those in. So I'm going to pass in DB context options builder as a type. I'll just hover over that and it just needs entity framework core, and I'm going to wrap that in parentheses because we're going to do a anonymous function over this. So we'll call this options, then we'll close those parentheses, and then we use an arrow function and say options dot use SQL server. I'm just going to put this onto a new line for clarity or readability. And then this is where we add a connection string. So we don't have a connection string yet, we need to set one up. So I've just opened SQL Management Studio, and I'm going to go to my databases and I'm going to say create a new database. So I just usually like to create a blank database to start with, and I'm just going to say demo database is the name. Click OK. And we should then see demo database is there. It won't have any tables, it's a fresh database. Then if we head back over to Visual Studio, one of the things you can do to easily get the connection string is go to Server Explorer and then make a connection to that database. So if we say add connection, and then for me, I'm using my local SQL server, so I'm just going to do // and then select the database. So I want a demo database, click OK. That will show me the database in data connections. If I right click it and click properties, on the right hand side here, you can see there is a connection string. So I'm using the Windows authentication, so that's just going to use the integrated security set to true. Now we need to put this somewhere in our application so that we can grab that string and use it as the connection string when setting up the context. So in Blazor, there's an app settings.json file. It might be a bit different in some other applications like ASP.NET MVC. Sometimes if it's not .NET Core, might be web.config, for example, but there's usually some kind of configuration file. For other applications like console apps, you can still use configuration files, but if you want to, you could store it in a text file. You could hard code it if you wanted to. It really is up to you. But for Blazor, I would say the best practice is to use your app settings.json file. Now, this is a JSON document, so you can format it in JSON format, obviously. And for this, I'm going to use connection strings, which is suggested already by Visual Studio. And connection strings is an object, so we'll just create that. And then you give the name of your connection string. So I'm going to call this connection string default. That's usually standard practice. And then you would paste in your connection string like so. This now means that you can access this configuration from elsewhere in the application and get that string so that you've always got your connection string somewhere handy. So I'm going to create a variable at the top of program.cs called connection string, and it's going to be equal to builder.configuration.getConnectionString. So this will go to the default connection string object, and then you can get it by its name. So you can say default. Now, one of the things I do like to do with these is do a null check. So I'll put a double question mark, and then I'll say if it's null, which it shouldn't be, but just in case, I'll say throw new null reference exception and say no connection string in config, exclamation mark. So at least we know that if this connection string was null in the JSON, or if it didn't exist, then we could throw an exception. So now we can go back to our add DbContextFactory function, and we can add connection string. And there we go. So we've added our DbContextFactory, which means because we've added that into the services in program.cs, when the application starts, it will create that service, and it will allow you to use dependency injection to inject that factory into other classes and therefore use the factory to get the context, which is your database connection. So at the moment, we've set up the dependency injection and everything like that in order to get the factory, which gives us access to the context, which gives us the tables and columns that we want. But at the moment, we have a blank database. How do we set up the database with tables? Okay, so let's go back to the demo DB context. And here we can define our DB sets, which are essentially the tables in the database. But in order to define those DB sets, they need to have some kind of model to model the table. So what we can do is create a few classes which model the tables we want to create. So if I create a new folder within data, so I'm going to go create a new folder, and I'm going to say that's called models. And we're going to create a new class, and we're going to use this as a table. So let's say we wanted a table called customer. So I'll create that, and then we're just going to set this up with properties as needed. So we've got a string called name. We can get it and we can set it, so we've got a property for that. We also want to be able to identify this customer uniquely. So it's good practice for these kinds of model tables to have a primary key, and you can do this by creating your property. So I'm going to say create an ID property, which is an integer, and by default that will use the incrementing identity column. So the first customer that's created, for example, would automatically get an ID of 1, and then it will go up 2, 3, 4 as you go. But at the moment, Entity Framework doesn't know that that's your primary key. So we use data annotations, which are attributes, to tell Entity Framework that this property is a key. So if I use square brackets and type key, at the moment that doesn't get recognized, but if I hover over it, show potential fixes, and we just need to add a using statement for data annotations. Now we've done that, when we eventually create the database table from C#, Entity Framework will see that key against the ID property, and it will say, okay, this is a primary key, it's an integer, so I'm going to create one that gets incremented one by one as records get added. So we've got an ID, we've got a name, we can create a, let's go age. That's been suggested to us by Visual Studio, which is great. And we could also say public, date time, created date as well. We'll do that as well. So that's our customer object, and this is basically a table that we're going to create in the database. We've created this inside a folder called models, and it's going to be now added to our context. So let's go back to our demo DbContext, and I'm going to add a new member called, well, it's a public DbSet, and it has a type of, and it's going to be customer. So then we'll call that customers, and we'll say get set. So then we'll just add a reference to the namespace data.models, and there we go. So we've told the context that we've got, oh, I've put that in the wrong place. I'll put that inside the constructor and put that inside the class. There we go. I'm going to give that a capital C as well. So we've got a DB set now of type customer called customers. So the idea here is that we are essentially scoping out what's going to be the schema of the database. But how do we actually get that schema created on the database side? Well, that's where migrations come in. So migrations are essentially a change log. So it's a way of understanding what you've changed in the code and translating that through to the database. So what you essentially do is whenever you make a change to your schema in the code, you add what's called a migration. You use a console command called add migration, and Entity Framework will look at all the changes, a little bit like Git when you do a commit, and it looks at all the changes that you've done and applies those changes to the branch. We're getting Entity Framework to look at the changes you've made. So in this case, the change we've made is we've added a DB set of type customer to our context, which means that we need to add a new table to the database. So if you say add migration, then you also have to give that migration a name. Typically, the best practice is to, again, similar to Git, like a commit message, write the change that you've made. So for me, I would say that this migration is added customers table. Once you've done that, it then updates a set of migration classes, and then you tell Entity Framework to then update the database. And the database has a track of which migrations it's already applied. So if it hasn't applied that migration, it will do so and it will update the schema. So let's go through this step by step. So in order to add your migration, you need to be able to type on the command line. Now I like to use the NuGet package console, or the package manager console. So if I go over to tools, NuGet package manager and package manager console, then you can access your command line from this package manager console at the bottom. And to add the migration, simply type add-migration. And then you need to pass a string, which is the title of the migration, or what you did. So I'm just going to say added underscore customer table. Press enter, and we've got an error. So what's the error here? Okay, the first thing that I've done wrong is I forgot to add another NuGet package. So we actually need to add another package on top of the two that we've already added in order to manage the database from the command line. And this is the Entity Framework tools. Nice and simple. If you head over to NuGet package manager and search for Entity Framework again, we should find the tools here. There we go. So framework core.tools, we'll add that. Again, I don't want the pre-release because I don't want any nasty surprises. Click install, finish off that installation, and then hopefully if I go back to my package manager console, if I try the same command again, I should be able to add that migration. So it builds the project first, and it looks like it has created the migration. And yes, so the way you can tell, obviously besides not having any error messages in the console, is that you'll have a migrations folder, and you will see two classes appear, a snapshot and the migration itself. So let's take a look at this then. So the snapshot is essentially a snapshot of your prospective database, so the database to be created. And you can see that there's some code here which is updating various columns and constraints and all that SQL stuff that you would probably do directly in SQL Management Studio if you were doing this directly against the database. But the key thing we are interested in is this migration class here. So typically, Visual Studio will create this, or Entity Framework will create this class with the timestamp followed by the title that you passed in when you created the migration. And what you can see here, if you look through, is essentially an abstraction of the SQL commands that will be run against the database. So this up essentially is when you're applying the changes, and down is reversing the changes. So if you had to reverse a migration, it would run this, whereas what we're going to be doing by default is applying the migration, and so up will run. And you can see here that we're creating a table. Its name is customers. It's adding a column of ID, which is of type integer, and it has the SQL Server identity applied to it, so it will increment 1, 2, 3, 4, and that will be the primary key. We've got the name column, which is an nvarchar max. We've got age, which will be an integer, and created date, which will be a date time. And then you can see, yeah, the constraints there is that primary key against ID. So, just by changing the code and adding a class of customer and then telling the DB context that customer is a DB set, therefore it's a table, we've been able to generate all this SQL code, which is going to apply everything to the database. So from a developer perspective, you can stay in C# for the most part, and you can just say, okay, I'm going to check the migration. Okay, that looks good. That's what I expect to happen. I want a new table. All those columns look good. So that's great. So we've got a map for what's going to get created on the database side. Now we want to apply it. So we'll head back over to the console, so the package manager console, and you can simply type update-database, press enter, and it should start running those SQL statements. So there we go, and there's no errors. So that looks good. Now if we go back over to the database just to take a look at this, and I'll click refresh, head over to tables, and you can see here we now have 2 tables. So by default, we always have this dbo.ef migrations history. We'll take a look at that in a second. The one we're concerned with is the customers table, which has now been created. So if I select the top 1000 rows, obviously there won't be any data, but you can see we have the columns we expected to have. We've got ID, name, age, and created date. So just by adding a class and then adding that class as a DB set in the context within C#, we've been able to create a table in our database. Now I mentioned that EF migrations history is a standard table whenever you're managing databases with Entity Framework Core. If we take a look at this, you can use this to see from the database side which migrations have been applied. And this makes sense because we can see this is the migration that we created in Visual Studio, and that's been applied to the database. And this is a really useful tool if you just want to see if the database is in sync with your code and what migrations you're expecting to be applied when you run the update database command. So let's also create another table then, and we could also start to create relations between the tables. Remember, SQL is a relational database, so you're going to have foreign keys which relate to other tables. So what we could do is create an orders table and have each orders table relate back to a specific customer with a foreign key relationship. So again, we'll repeat the process. We'll go to models, we'll say add new item, and we'll create an item called order. So it's a class called order, and we'll just do, again, we're going to create a primary key of ID. There we go, we've got that there. We're going to add the attribute of key and add a reference to data annotations as we did before. And then we'll do public string, we'll do a item description. We'll do an integer of quantity. So we can say how many have been ordered. And then this is the crucial bit. We want to add a relationship to a customer that's placed the order. So we can say public customer customer. And this should apply a relationship between the customers table and the orders table. So let's save that. We'll go over to our demo DB context. We'll add a new DB set of type order, and we'll call it orders. And then we'll add a new migration, and we'll call it added orders table. Press enter, it will build the project, and we should have a new migration, which I can see here. So if we look in that migration, we're creating a new table. We've also got a constraint which has the primary key, but it also has a foreign key relationship to customers on ID. So it should show a customer ID in that table. So let's test this. We'll go back to the Package Manager console. We'll type update database. And there we go. And let's just go back to SQL, refresh this database, go to orders, which is the new table we've created. And you can see here, we have a customer ID. We didn't tell it to add a column called customer ID, but we said that there is a customer reference on the table. So Entity Framework automatically told SQL, translated that in the migration to a foreign key relationship to the ID on the customer table. So this is really powerful. It allows you to create these relations really simply through code. So we've been through migrations and how to create the database, well, create the schema from C# using Entity Framework. Now let's take a look at how we can actually insert data, interact with the database through the front end of our Blazor application. So I'm going to create a page which we can use to add a new customer. So we can add the name, the age, all those properties that we add into the model in a form, submit the form, and have that data inserted into the database. So the first thing we want to do is create a service which can act as the means of retrieving data from our context or adding data to the database through the context. So it's kind of like a middle layer between the front end and the database. So I'm going to go over to our Solution Explorer. I'm going to create a folder on the project called Services. So this is what you tend to do with Blazor. Whenever you want to create a data layer, usually it's best to create a service which has the responsibility of speaking back and forth between the database, and the front end can then inject that service or use that service on the front end to then send data from the UI to the back end. So we're going to add a new class. So we're going to call this class Customer Service, and then click Add. And then we're going to start adding some properties. So the first thing we want to do is we want to make sure that we've got a DbContextFactory available on this service at any time, so that whenever we're using the service, we can use that factory to get a context. So I'm going to create a private member, and it's going to be an DbContextFactory. And if we then hover over that, we'll get the Entity Framework core reference. And I'm going to put an underscore for a private field, and I'll call this DbContextFactory. Then I'll put in a constructor for customer service. And on the constructor, I'm going to inject an DbContextFactory because we created the service in program.cs. Therefore, this is where we're going to use our dependency injection. So we're going to inject this into this service. I'll call this DbContextFactory without an underscore. And then in the body of this, we're going to say that our private DbContextFactory is set to the one we've injected. Now, one thing we forgot to put on here is the type. So it's an DbContextFactory of type T, So we need to specify the type of context, which will be demo DbContext. go, add that reference, and there we go. Same up here, demo DB context. So we have our private DbContextFactory, and we have that initialized through dependency injection in the constructor of this customer service class. So now I can add some CRUD actions. So I could create some functions which take care of updating, of retrieving, of querying, all that sort of stuff. So what we're concerned with for this is to be able to insert data. So I'm going to create a method called addCustomer, and that's going to take a customer parameter. So we'll add a reference to our models. So customer, and this is where we then get a context using the factory. So we'll use a using statement because it's using iDisposable, and we'll say we're making a new context which is the result of DbContextFactory, which is this up here, dot create DbContext, and that will use the DbContext builder options that are part of that factory to create a context to the database that's connected to. So now we've got access to our database through this context variable. So here, if I type context and then do a dot, you'll see all the different methods that we could access. And as you can see, one of the available items is customers, because there's a table called customers, or a DB set that we created called customers. There's also an orders object as well. So by adding or querying these objects, we are in effect adding to or querying from the database. So we want to add a customer to the database. So we would say context.customers.add, and then the customer that we pass in. And there we go, simple as that. So that's a very simple method, which means that from the front end, if we were to inject this service into a page, we could then call this service's addCustomer method, passing in a model, and the service will take care of adding it to the database. But how do we inject this service into the front end? Well, we did go over this in a previous video around Blazor specifically, but I'll just go over it very briefly. So because we've created a service here, we want to also register this for dependency injection. So I'm going to go builder back in program.cs, builder.services, and you can see there was a singleton added for the weather forecast service. So you can choose to say add singleton if you like, but I'm going to add a transient because I want to be able to have multiple instances of this if needed. So add transient, and it will be customer service. And we'll just get a reference to our services. There we go. So this service should now be available for dependency injection in a front-end page. So let's create a page. Or better yet, if we go to our index page, we could put it on the front page. So what I'm going to do is at the very top, I'm going to say at inject, because we want to inject our service. And I think it will also require a using statement. Yes, it will. There we go. So we inject an instance of customer service. And now we can use that service in the front end. So let's just create a brief form so that we can create this data from the UI and insert it into the database. So let's take a look at the model, because essentially we're building a customer. So we don't need to worry about an ID, but we do need to create a name, an age, and the created date we also need to handle from the service, because we need to be able to use the actual date or time that it was created. So really for us, the only things we want to be able to create from the front end are the name and the age. So we need an instance of a model in this front end page. So we need a customer model essentially. So down in the code section, I'll create a code section here, and I'll say var customer equals new customer. I just need to put in Blazor server demo dot data dot models. Cool. Cool. So we've got our customer instance. So in our edit form, we can create an input box. I'm going to use the Blazor HTML helper, and we'll give this an ID. And we'll call it name input. And we also want to bind this to a property on the model. So to do this in Blazor, you can say bind dash value. Then you would set that to customer dot name. So we've created a binding between this input and the customer property on the model. We also need to create a label for this. So just above it, I'll create a label and do a for attribute and say that it's for the ID of name input so that it links to that input text, and then we'll just put name. And then I'm just going to copy this and do the same thing for age. So for this one, we want to bind it to customer.age. Now the issue that I've got here is that age is actually an integer, so I need to change this to an input number so that I can pass in an integer, and it will enforce on the front end that I must use numbers and not text. Now I need to be able to handle submission of this form, and I haven't actually created a button yet, so I'm just going to put of type submit. And call that create. I think I'll also give it a class of button, just button primary, that'll be fine. Okay, cool. And then we need to be able to handle this. So let's create a method inside our code block called handle submit. And this will take an instance of edit context, which automatically comes from an edit form in Blazor. Now, one of the things we need to do with the form is actually give it a model. So we need to say at model equals, and then the model that we have created, so that when we pass this through for handle submit, it will have that model assigned to it. And that model that's sent through as part of the edit context will be an object. So we can then cast that back to its original object, which will be customer. So I'm going to create a variable called new customer, and I'm going to be casting this. So it's going to be customer, and then it's going to be the edit context dot model. So whatever the model object is, we're going to cast it back to a customer, which will give us access to the items that were bound. So we'll already have the name and the age. The ID we won't need to worry about, but we still need to update that date. So we can say new customer dot created date equals datetime dot now. And that will take care of updating the date to the point that it was submitted. Then we can use our service to add the object to the database. So we can access our customer service and then say add customer, passing in new customer. And there we go. Okay, so looking back at what we've done then, we've created our form. There was one thing I just needed to change, which I made a mistake on, which was that originally this model attribute had the @ symbol before it. We don't need to do that. We just need to specify the model using just the word model, and then obviously customer is our model as we've created a customer variable here. So now we've got our form, we now have to actually link that handle submit method to the submit event on this form itself. So for Blazor, we can say on an edit form, on valid submit equals, and then the method or function we want to use. So we can say handle submit, and that will then link the submission of this form to this method, and it will receive the edit context from the edit form. From that, as we saw, we can then parse the customer from the model and then handle the actual contact or interaction with the database via Entity Framework. So let's debug this. Let's run Blazor, and I'll put a breakpoint in this handle submit method. And here's the running app. Now the color scheme is a bit different because you may have seen in a previous video we changed some of the CSS and the styling on the application, so it's just the same project, which is why you're seeing that color. So here's our form. We just put it onto the main index page, so we've inserted it below the template that's on the first page you see on a Blazor application. So you can see that we have our name text box and our age text box, and then the create being the button we would use for submit. So I'm just going to put my name in there and my age, which is 34. Going to be very open. Click create, and you can see straight away we've hit our handle submit method. So we'll step through. We're going to create our new customer parsing from the model. So let's take a look at that. We've got age 34, created date at the moment is still incorrect. ID is 0 because there's no records in the database, and the name is Nick. So let's go to our add customer method. I'm going to step inside that. We're now inside our customer service. So we're going to create that context from the factory. So that context seems to have been created. That's our connection to the database. That's all good. And then we're going to run the customers.add. And there we go. Now, will we see this in the database? Now I'm going to say no, I wouldn't expect to see this in the database, and I'm going to show you why. So I've just opened up the demo database. I've gone to the customers table, and I've done a select star on that table, and as we can see there are no records. So there's a reason for this. There is an extra step we need to take in Entity Framework to actually commit the data that we're inserting. So if I go back over to our Blazor demo and take a look at the customer service, in here, this is where we're doing the customers.add. But at this point, we're simply adding the customer object to a DB set. So what we've added is still in memory. It's not persisted into the database. In order to persist what we've done or save the changes, we need to call a method on context called save changes. And what this will do is it will take the item that you've added in memory and it will actually execute the persistence to the database. So let's run this again. So I'm going to once again say Nick 34, 32, wishful thinking. Click create. We'll go back to our method, go into add customer, create the context, add the customer to the customers DB set, save changes, and that seems to have worked. You can see here in the output, you've actually got a SQL query which has been written out, which is the actual query that Entity Framework will have executed against the database. So if we go into the database and run the select star, you can see now we have a record, and it has an ID of 1, which we'd expect. The name, Nick, 34, and the created date is the date that what's the current date and time. So without that save changes, we're not actually committing the data. And this is a really good example of simply how we can insert something into the database. But we could use this similar method for other kinds of actions on the database. We could update a customer. We could select a customer. So for example, I could create another method inside this service called get customer by name, passing in a string called name. And what this means is I can say, obviously, get the context again. So I want the DbContextFactory create DbContext. So that gives us our connection to the database. And you can see Visual Studio is already giving us an example of how to get a customer by name. So I'm actually just going to type this out properly. So the customer we want is in context.customers, so in the customers table, and then we can say single or default, which means get a single record, or the default, which would be null if there were no records returned. And then we're going to use a lambda expression to say what the customer should be, what the actual condition is. So here we're executing a link query against the database. So we're saying for x, where x.name is equal to the name that was passed in. So it will find the first record, or null if it doesn't exist, where the name is whatever I pass in. So we could just test this by, I'm going to debug up to this point, and then when we get to this point, I'm just going to try to run this query in memory or in the immediates window in Visual Studio so we can get an idea of how it would run. So the app's running. I'm just going to put any old data in here, and then we're going to hit this handle submit. And here we are just about to save the changes, but I just want to try this method out while we're running. So in immediates in the bottom right, see if you can see that. Might be quite small writing, but I'm going to call that method, which was get customer by name, and then I'm going to type the string, which is Nick. I know there's a record in there for Nick. So we'll do that. And obviously I've made a big mistake there in that I've made the method void. I actually want to return a customer. So I'll say public customer, return customer. So something could call this and get a customer back. Obviously there's a possible null reference here because single or default could return null if there isn't a record, and so you'd have to do a null check on whichever method is calling get customer by name. So let's just get up to that point. So I'm going to call get customer by name Nick. That should just give us a customer, and there you go. If you can see that small writing there in the bottom right, we've got a customer, age 34, created date, ID is 1, and the name is Nick. And what we get back if we pass in an incorrect name, so if we look for John, we know there isn't a record in there with the name John, and it returns null. So we can see the query that was ran and the result being null. And so you'd be able to say if the result is null, then there are no customers for that record. We can also do updates. So if we were to make another method, public, we'll do void again. So update customer by, we'll say by name. So say for example you wanted to get the customer record by name and then update something on it. So if I wanted to change my age, for example, then I could call the above method that I just made. So I could say var customer equals get customer by name, passing in the name. Remember, I need to do a null check on it. So if customer equals null, I could throw an exception. Customer does not exist, cannot update, something like that. But if we do have a customer, then we could say customer.age equals, and then we could also pass in an age to this as well. So I could say int age, and then set that to age. So we've essentially pulled the customer record into memory from the database, and then we're editing it in memory, and we need to persist it again. So what we'd need to do is then get a context. So then we'd say var context equals DbContextFactory.create DbContext. I'm going to wrap that in a using statement. And then I can say context.update and then pass in a customer. So what this will do is it will find the record with the appropriate ID. So it will use the primary key, and it will overwrite that record with the new record that I've created in memory. And then obviously I want to save the changes. There we go. So just to go back over what we did, passed in a name to find the record and a new age. We then got the customer by name, and if it wasn't null, then we change its age. Then we get a context using our DbContextFactory. We use the update method to update the customer as per the latest version of that customer, and then we save the changes on the context. So again, I'm going to run the Blazor demo. So we're in the customer service, and then if I call update customer by name, passing in Nick and my new age, which is going to be 21, and then press enter, and there we go. So let's take a look at the database. 21. So you can see we've successfully updated an existing record. And it was as simple really as grabbing the appropriate record out of the database using a link query. So we used getCustomerByName to get our customer record. We then just changed the properties of that customer in memory and then recommitted it to the database with an update and save changes. There's also a remove method. So if you wanted to delete a record, you could say remove and then add in the customer that you want to remove. So that would actually delete that customer. And so you can see here how you would simply use the various link queries to get hold of a specific record and then make changes to that record as you need to. So just to sum up, we're getting the records from an in-memory dataset, and then we're changing them or inserting new records into that dataset and then committing the changes to the database from Entity Framework. Now, there's a lot of different things you can do with Entity Framework. Anything that you would do normally within SQL, for the most part, if it's to do with manipulating data in tables, you can do it in C# as well via Entity Framework. Obviously, if I was to create an order here, then what I could also do is then use getCustomerByName to get the appropriate customer and set the customer value of that order to that customer, and it would automatically link them together as relations in the database. And so you can see how it's quite simple as a higher level of abstraction to create those relations in C# rather than directly writing code in SQL. The other benefit of it is that it allows you to be a bit more defensive. So it's typically quite dangerous to make a developer sit in SQL Management Studio and write raw queries, because if they write the wrong drop statement or delete statement, they could be deleting production data. The thing with Entity Framework and wrapping the SQL in a C# bubble is that you can defend against things like that by saying, are you sure? Or just checking against, you could add in other defensive business logic to make sure that that record should actually be deleted, which is often quite important. So you can see that gives you a lot more versatility and a lot more safety in terms of how you interact with and manipulate your data in SQL. I really hope this has been useful as an introduction to Entity Framework Core. Probably going to do some more videos on Entity Framework in more detail, but if you have any ideas around Entity Framework or there's more questions that you have, then feel free to leave a comment below. And don't forget to hit the like and subscribe buttons. It really does help the channel, and I would really love to make some more .NET content, so please do subscribe. Until next time, keep coding, keep enjoying .NET, and I will see you soon for more C# goodness.